In these two examples, we're going to be finding some areas under the curves of some trig problems. They're a little bit tricky because they're trig. So when we have fractions, we have a tendency to have a U substitution kind of a situation. And when we have that, probably more often than not, your denominator ends up being your U. I will rewrite this one way that I'm going to do pi over 2, pi over 4. I don't like it when it has that power attached to here. I have a better feel for what's going on if I write it like this. It always just feels better for me. So most of the time when we have problems that have something that has a power on it, that has a tendency to be our U value. Now, trig gets a little tricky because when you have these situations, it's a little bit nicer to say, well, the derivative of x squared is an x, so then that's going to have to be my U. So, but the problem with trig is the derivative of cosine is a sine, it has a negative on it, but as far as term-wise, it's correct. And then the derivative of sine is a cosine. So it's like, well, which one is the derivative of which? Whatever has something to a power, have that one be your U. And so I'm going to let U equal sine of x du is going to equal cosine of x dx. All right, so let me do one more rewrite, and that is I'm going to pull the fraction off. Well, let's do that all in one step. Should have done that anyway. So 1 over, let's pull the fraction off like that. So now here is that perfect match. And when I do sine, I get a cosine. And so I can sub that out with a du. I can sub that out with a u. And then I'll have to change my bounds because everything's going to be in terms of u. So I have a 1 over u squared du is now what I'm doing the antiderivative of. And so I need to plug in these values to turn them into in terms of u, basically. So I'm going to do sine of a half, or sine of pi over 2, and I'm going to be doing sine of pi over 4. So sine of 1/2 is, if I think of the sine curve, sine of 1/2 is 1. There's my upper bound. And then sine of pi over 4 is a point on that graph, but that's trickier. It comes from the 45, 45, right triangle. So sine of pi over 4 is sine of 45, so opposite over adjacent. I'm going to 1 over root 2, better known as a root 2 over 2. And that is my lower bound. Okay, so let me get this ready to do the antiderivative, and then we'll actually do it. And that means we're going to go from root 2 over 2 to 1. This is going to be a u to the negative 2. Now I could add a power, divide by the power. So let's do the antiderivative. So add a power. So that's a u to the negative 1 divided by that power. And we're going from root 2 over 2 to 1. Let's plug things in and start to do some math on it. Well, let me do one last thing. Let's rewrite this as a negative 1 over u from root 2 over 2 to 1. All right, now we can work through the math. So if we plug in a 1 here, we'll start off with a negative 1 over 1 minus a negative 1 over root 2 over 2. Got to figure out some math on that one. And then this is going to become a negative 1 plus, instead of this, we're going to take 1 multiplied by its reciprocal. And then that's going to become a 2 over root 2. So let's go ahead and rationalize that, and then we can get a common denominator and put things together. So if I rationalize this, that's a root 2 over 2, root 2 over 2. So we're looking at a 2 root 2 over 2. That's a negative 1 plus that. 2's can go away. And so we would get a -1 plus √2. And that would be our area under that curve. So trig actually, once you subbed out your u's, ended up becoming something that wasn't a trig. So let's do the last one here. All right, so this one. First thing I'm going to probably do is take that 8 out of there. Why leave it? So 8 going from pi over 16 to pi over 8. And then this cosecant squared of 4x dx. Normally, I like to take this and rewrite this square on the outside. However, I know that I have to think derivative-wise. And so the derivative of something is cosecant squared. And if you remember, we have this, get rid of p. So this one, just a quick refresher, is the derivative of secant is secant tangent. Derivative of tangent is secant squared. But we have a cosecant squared, and that's us changing these to a cosecant, and I put a negative in the middle one because the derivative of any co is a negative. So the derivative of cosecant is negative cosecant cotangent. Derivative of cotangent is negative cosecant squared. So there's our negative cosecant squared. So we're undoing it. And so little thing that we have to account for is this, though, this 4x. So here's where let's take this. Let's let 4x equal u. Du is going to equal 4 dx. We'll take the 1/4 over, or take the 4 over, make it a 1/4. And so we're going to rewrite things. So I'm going to sub in the 1/4. And this is now going to become a cosecant squared of u du. All right, because this works perfectly with the formula. And so we have that 4th in there because the chain rule, if you did the derivative, you'd have a derivative of 4x with giving a 4. That's going to undo it. Next thing is I'm going to adjust my bounds. So if I take a pi over 8 and I plug it into this, if I take a pi over 8 times 4, I'm getting a pi over 2. And if I take a pi over 16 and multiply it by 4, I'm getting a pi over 4. All right, so if I do the derivative, I have pi over 2, pi over 4, right? I'm leaving everything in terms of u, so I'm going to do the antiderivative now. So a 4th of 8 is going to be 2. The antiderivative of cosecant squared is cosecant squared becomes cotangent, but I do have to apply a negative onto it. So it's negative cotangent of u from pi over 4, pi over 2. All right, it is a cotangent, so I do have to kind of maybe think in terms of tangent versus cotangent. So let's see what we got. We're going to do a 2. I'll pull the negative, might as well just pull the negative onto that. And then I'll do cotangent of pi over 2 minus cotangent of pi over 4. And then whatever that is, we'll go ahead and distribute a -2 into it. So let's do a little side work here. Cotangent of pi over 2. Cotangent of pi over 2 is actually the same thing as cotangent is cosine over sine. So you can do cosine of pi over 2 divided by sine of pi over 2. And that cosine is, cosine graph looks like that. There's the pi over 2. So that's going to be a 0. Sine looks like that. So that's going to be a 1. So 0 over 1 is 0. So a -2 times 0 minus cotangent of pi over 4, same idea. that we're going to have cotangent of pi over 4. Let me go this route. Cotangent of pi over 4 is really 1 over tangent of pi over 4. And tangent of 45 is 1. And so that's going to be a 1 over 1. So you're going to want to have that. All right, so if we distribute, this is really just a -1 times a -2, and we're getting an area of 2. So that is 2 little bit more challenging problems, all related to trig, which just has its own kind of trickiness to it. And we're talking about unit circle kind of information that also gets thrown into this mix, and some substitutions that are not always consistent.